Good day wherever you are viewing us from, and you are welcome to MLT Channels, an online resource that specializes in preparing candidates for external exams such as SSCE, UTME, Post-UTME, IGCSE, IELTS, TOEFL, SAT, GRE, etc. We ease admission processing for candidates seeking admission into tertiary institutions, and we have helped numerous students to achieve their grades and secured admission into their most preferred university. We are dedicated and determined in achieving excellence in all our endeavors. Try us today. Success awaits. In today's class, the subject matter is physics, and the topic under discussion is position, distance, and displacement. You are all welcome on board. I'll remain my humble self, Engineer Oladipo, your host and your amiable online tutor. Without wasting much time, let's quickly dive into what we have for today. And the first thing we shall be looking at are the aims and the performance objectives of today's class. At the end of lesson, learners should be able to describe position, distance, and displacement, perform simple calculations involving position, distance, and displacement, as well as state the applications of position, distance, and displacement in real-life world. Now, we have warm-up question which will serve as the prerequisite or the entry behavior to have a solid background on the topic of discussion today. And the warm-up questions are: 1. What is distance? 2. Define displacement. 3. What is Cartesian plane? 4. State the similarities and differences between distance and displacement. And finally, what is GPS? Convince yourself that if you can answer all these questions correctly, that implies that you have a solid background on this topic, and that will go a long way in assisting you to master the root and the rudiments and the metamorphosis of this topic. Now, let's go into details. And the first thing we shall be looking at is position. And what do we mean by position? What is position? Simply, position is not actually a physical quantity. It is rather used to express two physical quantities, which are distance and displacement. And simply, the position of a body on a plane or in a space can be determined by knowing the distance and the direction of the body from reference points. What is the meaning of that? That implies that if a body is on a plane, we are looking at a body that is resting or sitting on a surface or in a space. We are talking about a flying object. We can determine their position. How? All what we need to know is just the distance and the direction of such bodies from the reference point. So the next argument is now, what is that now reference point? A reference point is simply the starting point or the origin where the observer is trying to locate a position. And this is commonly known as coordinate in science. Coordinate is simply divided into abscissa, which is known as the x-axis, and the ordinate, which is known as the y-axis. And coordinate is written as x, y. That implies that in writing our coordinate on Cartesian plane, we pick the x-axis before we pick the y-axis. Now, before going away on this slide, don't forget that we were looking at position on the third slide. And the position of the body, either the body is flying or the body is resting on a surface, the position of that body will depend on where the observer is, which is the reference point. And the reference point is simply the starting point or the coordinate. And our coordinate is divided into x. Wherever we are on the surface of the earth is x, and also the y. That is when we are going up. Then it's written as x, y. I hope this is clear enough. If this is clear enough, let's move to the next slide. And under this slide, we have a quiz. The first question: determine the position of point A in the figure, and look at point A. To know the position of this point A, our reference point will be the origin, which is 0 here. And according to the diagram we have here, to locate the position of A, that will be x, y, and on x-axis A is at point 2, and our y-axis A is at -5. That implies that the position of point A on this Cartesian plane is 2, -5. Then with that, I'm challenging you to try the second question. Sketch the coordinate of A, which is 2, 3, as well as point B, which is -5, 1. Then moving to distance. What is distance? Distance is simply how far an object has traveled, or the length between 2 points. And additional information: distance is actually a scalar quantity, and its SI unit of distance is meter. Then we need to familiarize ourselves with the unit of distance, because sometimes in question we may be given the distance in centimeter, and sometimes we may be given the distance in millimeter. If that is the case, that shouldn't be a problem. If we could remember our metric unit very well, right from our primary school days, we were taught that 10 millimeter make 1 centimeter, 10 centimeter make 1 decimeter, and 10 decimeter make 1 meter. So the application of this, what we have learned right from our primary school days, is now what we need in physics. Anytime we are given our distance in centimeter, we have to convert it to meter by dividing it by 100. And anytime we are given our distance in millimeter, we have to convert it by 1000 in converting it to meter. And also, we could have larger unit of distance, and the larger unit of distance, 1000 meters, will give us 1 kilometer. And before we move away from this slide, we should remember that we have defined distance as how far an object has traveled, or the length between 2 points. And additionally, we have established that the distance is scalar quantity, and the SI unit is meter. And we have smaller unit of meter, which are the milli, the centi, and the deci. And we also have the larger unit of meter, which is the kilometer. So on to the next slide now. On this slide, we have a cyclist who is covering a distance from a starting point, which is point A, to point B, and he continued his journey from point B and finally arrived at point C, which is his destination. To know the total distance he has covered, we just sum up the distance he covered between point A and B, in addition to the distance he covered between point B and C, and convince yourself that point AB is 4 meter, also point BC is 3 meter. That implies that the total distance covered by this cyclist is actually 7 meter. Then a brilliant or a curious student will ask, what happened to line AC? Why is this not considered as part of the distance covered by the cyclist? Well, line AC is the displacement, it's not actually the distance, and that is what we shall be looking at under the next subtopic, which is displacement. But before we move to displacement, let's see how we can calculate distance between a body that is on a plane. That implies distance between 2 points, and distance between a body that is in a space. That's distance between 3 points. And I'll take us to the next slide. On this slide now, this slide is looking at how to determine distance between 2 points. If you have 2 points, X and Y, and want to determine the distance between them, the formula is given as S, which is the distance, is equals to square root of x2 minus x1 all squared plus y2 minus y1 all squared. We now have a question here to try. Determine the distance between point P and point Q. So to know the distance, that is the task at hand, what we need to do is that we need to get the coordinates of our point P and point Q. And simply, point P on the x-axis, it is 5, while on the y-axis, it is 2, according to our x and y coordinate. Then point Q on our x-axis, it is -3, while on the y-axis, it is 4. So now let's try this on the next slide. So we are looking for the distance between point P and point Q, and the formula have been given in the previous slide, which is x2 minus x1 into bracket x2 minus x1 all squared into bracket y2 minus y1 all squared. So without wasting time, let's quickly simplify this question. And the first thing we need to establish is to identify the problem. What is the problem at hand? And the problem is that we want to get distance between 2 points. And what are the points given? We have our x-axis, our x1, according to the question, which is equals to 5. And we also have our x2, which is equals to our x2, which is equals to -3. Then our y1, according to the question, is 2, while our y2 is equals to 4. Now, substituting all this into the formula that we were given in the previous slide, then that implies that we have x2, which is -3, minus x1, which is 5, all squared, plus y2, which is 4, minus y1, which is 2, all squared. Then we perform our arithmetic. -3 minus 5, that will give us -8. And -8 squared, that will give us 64. Plus 4 minus 2, that will give us 2. 2 squared, that will give us 4. That implies that we need to look for the square root of 64. And if you perform your arithmetic, or rather square root of 68. So if you perform your arithmetic, or you press your calculator very well, square root of 68 should give us 8.2. That should give us 8.25, which is actually the distance between point Q and point P that the question is asking us. I hope that is clear and self-explanatory enough. Then if that is the case, let's look at how we can calculate distance between 3 points. For instance, a body that is in space. So to get that, the formula extends to x, y, and z. And the formula is the distance between 3 points is equals to square root of x2 minus x1 all squared plus y2 minus y1 all squared plus z2 minus z1 all squared. So the next thing is, let's just identify our point. Our x1, according to the question, is -5. Then our x1 is -5. Okay. Our x1 is -5. Then our x2 equal to -3. Our y1, okay, let's use the next slide. It seems this slide cannot really accommodate that any longer. Okay. Our 1 equals to minus 5, x2 equal minus 3, y1 equals to 2, y2 equals to 7, z1 equals to 0, yz2 equal to 4. Now let's use the next slide to simplify that. So going with that, let's get our values. X1 equal to x1 equal to 5, then x2 equal to x2 equal to minus 3, y1 equal to 2, y2 equal to 7, then z1 equal to 0, yz2 equal to 4. Now substituting this into the formula, we have x2, which is minus 3, minus x1, which is 5, all squared, plus y2 7 minus y1 2 all squared, plus z2 4 minus z1 0 also all squared. Now the next thing is just to perform our arithmetic. X2 minus x1, that is minus 8. Then minus 8 squared, that will give us 64. Oh, it seems the slide is, we have exhausted the slide, but we just have to manage what we have. We have to manage what we have. So s equal to square root of x2 minus x1, that is minus 3 minus 5, that is minus 8. The minus 8 squared, that is 64, plus oh, that's a problem now because we are okay, plus y2 minus y1, that is 7 minus 2, that's 5, and 5 squared, that is 25, plus z2 minus z1, that is 4, and 4 squared equal to 16. Now if we sum that up, we have 64 plus 25 plus 16, that gives us 105, and square root of 105, that is 10.2. That implies that our answer here is 10.2, which is actually the distance between the 3 points, which is actually the distance between the 3 points. I hope this is also clear enough. Then if this is clear enough, let's move to the next subtopic, which is displacement. And what is displacement? Then how is it similar with distance? Actually, displacement is also a distance, but what kind of distance? A distance that is covered in a specified direction. Displacement, additional information. Displacement is a vector quantity and it starts the same unit as distance, which is meter. What are now the similarities between displacement and meter? Both distance and displacement are fundamental quantity and they both have the same unit, which is meter. And the major difference between them is that distance is scalar while displacement is vector. Alright, on to the next slide. This slide is now explaining to us the main difference between distance and displacement in terms of pictorial view. We have a house here. From this house to this water, is going to take a distance of 400 meters. Before an observer can cover this distance, such observer must have traveled for 400 meters. But same 2 points, the observer can take a shortcut along the northeastern direction and cover just a distance of 100 meters in a specified direction of north, probably 45 degrees east. And that's actually what displacement is. And we have that here. The distance from the house to the stream is 400 meters, while displacement from the house to the stream is 100 meters. What we need to take note here is that displacement actually is looking at where an observer is with respect to where he's starting from. The next slide will shed more light. Now we have an example here. Example 1. A boy travels 12 kilometers eastwards and then 5 kilometers southwards. Calculate the difference between the magnitude of the displacement of the boy and the direction traveled by him. Oh, that direction is supposed to be and the distance traveled by him. That must be a typographical error. And this is a very simple task, but what we need to first identify is what is the task at hand, what is the problem at hand. And the problem at hand is the difference between the distance covered by the boy and the displacement traveled by him. If we represent our s with distance and our displacement with x, this is actually what we are looking for. Then the next is to interpret this diagrammatically and look for the solution to the question. And in doing that, let's use the next slide to try that question. So now, onto the next slide. First, let's put the diagram down. If we assume that the boy started from this point, then he traveled 12 kilometers east. Then he later changed his course and now move 5 kilometers south. This is actually the distance the boy has covered. So simply, to know the distance he has covered, that will be equal to, the distance covered will be equals to 12 plus 5, and that will be equals to 17 kilometers. So this observer has traveled a distance of 17 kilometers. What about the displacement? To know his displacement, we have to complete this diagram. If we name this point A, B, and C, the observer stopped at point C, and to know his displacement, that will be where he stopped from where he started from. So this line AC represents our displacement, and his journey now has now formed a right angle triangle. So we can actually use Pythagoras theorem to solve this. So using the Pythagoras theorem, the longest side, which is the hypotenuse side, which is the same thing as line AC, is equals to the sum of the square of the other two sides. And line AB is 12, that will be 12 squared, while line BC is 5, and that will be 5 squared. Then we perform our arithmetic. 12 squared is 144, and 5 squared is 25. So if we had 144 with 25, that will give us 169, and we have to actually look for the square root of 169 because AC is squared, and the square root of 169, that will give us 13 kilometers. That implies that the displacement covered by him is 13 kilometers. But that's not our final answer. The question is, we should get the difference between the distance and the displacement covered by him. Then we have already calculated the distance to be equal to 17 kilometers, then minus the displacement, which is 13 kilometers. Therefore, our final answer is 4 kilometers, which is actually the difference between the distance and the displacement covered by the observer. And I hope this is also clear enough. Okay, if the screen is not allowing that, let's put that here. That means the distance minus the displacement is equals to 14 kilometers. Okay, now looking at one more question. Example 2. An object moves along the grid through point A, B, C, D, and F as shown below. So we have the diagram in the next slide. That's the diagram to question 2. Then the side of square tiles measures 0.5 kilometer. That implies that each of these tiles along both the vertical and the horizontal is 0.5, since it's a square, and we all know that all the sides of a square are equal. Now, what did the question want us to do? The question first wants us to calculate distance covered by the moving object, and secondly, to find the magnitude of the displacement. Now, let's use the second slide. Now, using the second slide, to get this distance, which is S, the distance covered by the moving object will be the distance covered during line AB plus the distance covered during line BC plus the distance covered during line DE plus the distance covered during line EF, and that will give us the total distance covered by the moving object. And now we need to calculate that if each of these tiles is 0.5. So here it will be 0.5, here will be 1, 1.5, 2, then 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5. That implies that the total distance covered by the moving object is 6.5 kilometers. And that is the answer to the A part of the question. Now, trying the B part of the question. The B part of the question wants us to get the displacement. And we have established that earlier. Displacement is the distance from where the observer or the object stops with respect to where the object started from. So this line AF is actually our displacement. And to get our displacement now, we need to resolve this journey into x and y axis. If from where it stopped, we draw a line vertically downward. So, and take it back to where it started from. This has formed a right angle triangle. Along the horizontal, we have 1, 2, 3, 4. So we have 4 ties along the horizontal. That implies that our line, if we call this point G, our line AG will be 2 kilometers. Then line GF 1, 2, 3, that will be 1.5 kilometers. Now we can now get the longest side now, which is line AF, and line AF is actually the displacement that we are looking for. We can use Pythagoras theorem to get that, and line AF now will be equals to the sum of the square of the other two sides, which is line AG squared, plus line AG squared plus line FG squared. Also our AS will also be squared. Then now substitute the values into the equation. Then we quickly take square root because of limited space we have, since our AF is squared. Then our AG is 2 plus our GFG or GF, that will be 2 squared plus 1.5 squared. And without wasting time, 2 squared, that will give us 4 plus 1.5 squared, that will give us 2.25. And that implies that will give us 2.25. That implies that our line AF now will be square root of 6.5. And if you perform your arithmetic or you punch your calculator very well, our AF will now be that will be equals to 2.5 kilometers. Square root of 6.5, that will give us 2.5 kilometers. And that is actually the B part of the question. Ladies and gents, I hope this is clear enough. Then if this is clear enough, now this is the class drill that we are supposed to try. And this is taking us to the evaluation to assess what we have been learning so far. So far, we've been talking about position, distance, and displacement. And at the commencement of the class, we highlighted the aim of the class, which are, by the end of this lesson, students should be able to describe position, distance, and displacement. And I believe by now, if you have followed what we have been doing so far during the lecture, you should be able to describe position, distance, and displacement. And also perform simple calculation involving position, distance, and displacement. At least we've tried some examples under position, distance, and displacement. We first look at how to determine the position of an object on the third slide. Then we went ahead to look at how to calculate distance covered by a moving body. We also look at distance between 2 points, probably on a plane. We went ahead to look at distance between 3 points, probably an object that is in a space. Then we didn't stop there. We took examples on how to determine displacement covered by a body. We tried 2 examples on that, and finally we are now at class drill, where we can assess what we have learned so far. So we have 3 questions here. Question 1: a man walks 1 kilometer due east and then 1 kilometer due north. What is his displacement? Question 2: a lorry travels 10 kilometers northwards, 4 kilometers eastwards, 6 kilometers southwards, and then 4 kilometers westward to arrive at point E. What is the total displacement? While the final question for the day: an aircraft traveled from Calabar to Kano as follows. It flew first to Ilorin, covering a distance of 300 kilometers, 30 degrees west of north, and then flew 60 degrees east of north to Kano. What is its resultant displacement? I will advise us to try this as evaluation to assess what I have learned so far during the course of the lecture. And also, we should also lay our hands on the warm-up question in order to achieve the aim of today's class. If you have gained 1 or 2 things in today's class, do not hesitate to join us again in the next class. And you can also attend our physical class. We have our office at Omega Building, opposite Gangland Station, Obafemi Awolowo Way, Malete, Ibadan. At MLT, we are your road into university. Well, 34 minutes gone like 34 seconds. It's been wonderful informative, educative, and enlightening. Don't hesitate to register with us with a token amount and start preparing for your external exams, such as the WAEC and the NECO that are around the corner, as well as your UTME. At MLT, our symbol is excellence, and we are determined and dedicated to always achieve that. With this, that will be the convenient point to say bye-bye for today's class. And if you really enjoy us, do not hesitate to join us again. You can always check out our social media handles. We are on Facebook, WhatsApp, Instagram, Telegram, and so on. You can also check out our website on www.mlttechspace.wordpress.com. I remain my humble self, Engineer Oladepo Olalekan Nuruddin, your host and your amiable online tutor. Bye for now.